Hello, it's Professor Asma Parveen from Department of Psychology, Aligarh Muslim University. Today I will be talking about the next method of random sampling techniques, that is cluster sampling. This method is used by researchers to study large populations, such as cities or countries, when it is difficult or costly to identify each individual. Instead of selecting individuals one by one, the population is divided into groups called clusters. These clusters can be based on factors like location or a common characteristic related to the main topic of the study. Once the clusters are formed, researchers use a technique called simple random sampling to select elements within each cluster. The way the clusters are organized determines at what level the sampling is done. This method allows researchers to gather data effectively and efficiently without having to individually survey every person in the population. For example, if a researcher wants to study the eating habits of people in a city, they may divide the city into different neighborhoods. Each neighborhood would then become a cluster. From there, the researcher would randomly select a certain number of households within each neighborhood to participate in the study. By doing this, the researcher can obtain a representative sample of the city's population without having to survey every single person. Cluster sampling is particularly useful when the population is geographically dispersed or when it is not feasible to reach every individual. It also helps to reduce cost and time required for data collection. In social surveys, cluster sampling, also known as area sampling, and this is used to study large populations without having to contact every individual of the population. Instead, researchers identify specific clusters within the population and randomly select a certain number of them for data collection. For example, if we want to study a company with offices in 10 cities across the country, rather than visiting every office, researchers can use random sampling to choose 3 offices as cluster for data collection. This approach offers a more efficient way to collect data, but it is important to recognize that there may be differences between the clusters that could impact the results. Therefore, researchers must carefully select the clusters to ensure they accurately represent the entire population. In the case of company with multiple offices, they would need to consider factors such as the number of employees and their roles in each office to ensure a representative sample. By using cluster sampling, researchers can obtain valuable insights into the large populations while saving time and resources, and it allows researchers to generalize findings from the selected clusters to the entire population. Another example of cluster sampling would be in market research. For example, companies frequently employ cluster sampling to gather data on consumer preferences. By selecting specific neighborhoods or regions as clusters, they can survey a sample of individuals within those areas, providing valuable insights into consumer behavior. Similarly, in public health studies, cluster sampling is often utilized to investigate the prevalence of diseases across different communities. Researchers may choose clusters such as schools or hospitals, enabling them to efficiently collect data from a diverse range of individuals. All these examples highlight the practicality and usefulness of cluster sampling in obtaining relevant information and insights. When we compare cluster sampling with the stratified sampling, we will find that both the methods are commonly used, each offering different advantages and disadvantages. Cluster sampling involves dividing the population into groups or clusters, and randomly selecting a few clusters to represent the entire population. On the other hand, stratified sampling involves dividing the population into homogeneous subgroups or known as strata and randomly selecting individuals from each stratum. While cluster sampling is more cost effective and easier to implement, stratified sampling provides more precise estimates and reduces the risk of bias. Ultimately, the choice between the two methods depends on the specific research objectives, available resources, and the desired level of precision. Cluster sampling has various advantages, and firstly, it is cost effective approach, particularly when the measurement of each unit does not require a significant amount of money. This means that resources can be allocated efficiently, allowing for more accurate data collection. Additionally, cluster sampling also saves time and money as it involves grouping individuals or elements together based on their similarities. This makes easier to access the desired population, reducing the need for extensive travel or logistical arrangements. Moreover, implementing cluster sampling is relatively simple, making it an accessible option for researchers and practitioners alike. Overall, these benefits make cluster sampling an attractive choice for gathering data in a cost efficient and accurate manner. Though cluster sampling is a very valuable tool for gathering data from large populations, but it does have its limitations. And one of the limitation or drawback of this method is the potential for increased sampling error. Instead of selecting individual units, clusters are chosen, which can introduce bias and affect the accuracy of the data collected. Additionally, there may be more variability within clusters compared to individual units, resulting in a loss of precision. To mitigate these issues, careful consideration must be given to the size and number of clusters selected to ensure representative results. However, this process can be complex and time consuming, especially with large and spread out populations. Another limitation of cluster sampling is the possibility of introducing bias into the study if the chosen clusters do not truly represent the entire population. This means that the results may not accurately reflect what is happening in the population as a whole. Furthermore, analyzing the data collected through cluster sampling can be more complicated compared to other sampling methods. It requires careful planning and consideration of the characteristics of the clusters to ensure they accurately represent the population. Despite these limitations, cluster sampling remains an important tool for researchers when studying large populations. Next is multi stage sampling, that is the more advanced method of cluster sampling. It is used in statistics to take samples in stages using smaller and smaller groups at each stage. That is why it is known as multi stage sampling. It can be a bit complex because it involves dividing the population into clusters and then randomly selecting one or more clusters to sample from. Instead of using all the elements in the selected clusters, the researchers randomly selects elements from each cluster. This method is useful when a complete list of all the members of the population does not exist or is inappropriate. In multi-stage sampling, several levels of cluster selection may be applied before the final sample elements are reached. Each stage in multi stage sampling is like a separate step in the process, allowing for different methods to be used. For example, when dealing with a large population, it can be helpful to divide the initial steps into smaller groups and use random selections for the final steps. To better understand this concept of multi stage sampling, let us consider an example of a city where we do not have exact data on all the residents. We can divide the city into zones based on information from the municipality. Then we can further divide each zone into wards. From there, we can select clusters from the wards, ensuring that every zone is represented. For example, if there are 6 zones and 10 wards in each zone, it means there are in total 60 wards. We could choose 2 wards from each zone. Next, we would select 2 clusters, each consisting of 10 people from each ward. By following this method, we can gather a sufficient sample of 120 respondents who represent the entire city. This approach allows us to obtain a diverse range of perspectives and characteristics from different areas within the city. It ensures that our sample is representative of the entire population, even if we do not have precise data on every resident. Multi stage sampling provides a systematic way to collect data in large scale surveys. It allows researchers to break down the sampling process into manageable steps, making it easier to select individuals or households. By using different methods at each stage, researchers can ensure that their sample is diverse and representative of the population they are studying. In the example of this city, dividing it into zones and wards helps to organize the sampling process and ensure that every area is included. So, by selecting clusters from each ward, researchers can gather a sufficient sample size that accurately represents the entire city. This method helps researchers to gather data on various aspects of the population even when precise information is not available for every resident. Multi stage sampling is a method that researchers use to efficiently gather data from widespread populations. Instead of selecting individuals, they choose groups of people as the main units for sampling. By selecting clusters of people rather than each person individually, researchers can still obtain representative data while reducing the cost associated with collecting and processing information. Another advantage of multi stage sampling is its cost effectiveness. It eliminates the need for extensive sampling frames and resources. Instead of sampling each person individually, researchers only need to sample clusters of people. This helps them to save money but also helps them to streamline the data collection process. So, by focusing on groups rather than individuals, researchers can obtain accurate data without incurring unnecessary expenses. Another aspect of multi-stage sampling is its efficiency in dealing with large and spread out populations. When the population is vast and geographically dispersed, it becomes challenging to reach. Another advantage of multi-stage sampling is its ability to provide more accurate information about the geographic representation of the population. To accurately understand the whole population, it is important to have a diverse group of people that represents different areas or regions. Multi-stage sampling allows researchers to select samples from various locations, providing a better understanding of how the population differs in different areas. By incorporating this method, the sample becomes more representative of the population, enhancing the validity and reliability of the study. In addition to capturing the diversity of the population, multi stage sampling also helps researchers to account for variations within each cluster and helps to make more precise results. By selecting samples from different locations, researchers can ensure that their findings are not biased towards one particular area. This ensures a more balanced representation of the population as a whole. Furthermore, multi stage sampling allows researchers to analyze data at different levels. They can examine patterns and trends both within individual clusters and across the entire population. This comprehensive analysis provides a more holistic understanding of the population's characteristics and helps to identify any unique factor that may exist within specific clusters. Multi-stage sampling also allows researchers to meet the specific needs of their research. That is, this approach offers flexibility by allowing adjustments in the number of stages, cluster size, and sampling methods based on the characteristic of the population being studied and the available resources. Researchers can customize their sampling process to ensure it aligns with their research objectives and goals. By utilizing multi stage sampling, researchers have greater control over the composition of their sample, enabling them to gather more accurate and representative data. This method helps researchers to make informed decisions about how to best collect data for their studies. Another important advantage of multi stage sampling is the sampling of the rare populations. Because sampling of rare populations is an important aspect for research as it helps us to study groups of people who are often overlooked due to their rarity or difficulty in reaching them. To achieve this, we can utilize multi-stage sampling method. This method involves selecting groups that have a higher concentration of these rare individuals and then choosing specific individuals within those groups to be part of the study. By using this approach, researchers can ensure that these rare populations are included in the sample even if they only represent a small proportion of the overall population. This enables a more comprehensive understanding of diverse groups and helps to avoid biases that may arise from excluding these rare populations. Another important advantage of multi stage sampling is its adaptability to complex sampling designs. It is a method that helps researchers to select samples in complex ways. So, by incorporating methods such as stratification and oversampling at different stages of the sampling process, this method enables researchers to target specific research questions or goals while ensuring the sample remains accurate and representative. This approach is particularly helpful when dealing with intricate sampling scenarios, providing flexibility and precision in data collection. Multi-stage sampling involves stratified random sampling, which is a technique that involves dividing the population into distinct groups or strata based on certain characteristics. Within each stratum, a random sample is then selected. This method ensures that each subgroup within the population has representation in the sample, allowing for more precise analysis and generalization of results. Stratified random sampling is especially beneficial when there are significant variations within the population and it helps to capture the diversity present. Researchers can obtain a comprehensive understanding of the entire population by employing this method effectively. Multi-stage sampling also allows researchers to use oversampling. It is a technique used to intentionally overrepresent certain groups or characteristics in a sample. This method is employed when researchers want to ensure sufficient representation of underrepresented groups or when they need to analyze specific subgroups separately. By deliberately increasing the number of individuals from these groups in the sample, researchers can obtain more accurate estimates and draw meaningful conclusions about these populations. Oversampling allows for a more deep examination of diverse perspectives and experiences, contributing to a comprehensive understanding of the research topic. Another advantage is ease of implementation. This multi stage sampling is a method that is relatively straightforward as compared to other complex techniques like probability proportional to size sampling or systematic sampling. With careful planning and organization, researchers can successfully conduct multi stage sampling studies with minimal logistical challenges. This approach involves dividing the population into small groups or stages and then selecting samples from each stage to gather data. By breaking down the population into manageable segments, researchers can efficiently collect information without overwhelming themselves with the entire population at once. This method proves to be an effective way to obtain representative data while maintaining practicality and ease of implementation. So, in conclusion, we can say that multi stage sampling is a practical and efficient method for researchers to gather data. Its ease of use, flexibility, and cost effectiveness make it a valuable tool in the field of research. By dividing the population into clusters and selecting samples at different stages, researchers can obtain a representative sample without surveying every individual. This method saves time, resources, and ensures unbiased results. Whether conducting a study in a small community or a large city, multi stage sampling can be adapted to suit the needs of the research and collect data in a comprehensive and efficient manner. But this multi stage sampling method also has certain disadvantages. And one of the drawback or disadvantage of this multi-stage sampling is the increased complexity it introduces. Unlike simple random sampling, which involves randomly selecting individuals from the entire population, multi-stage sampling requires multiple stages of selection. This can make the sampling process more time consuming and resource intensive. Researchers must identify and select clusters at each stage, which can be challenging and may require additional logistical considerations. Additionally, the analysis of data collected through multi stage sampling can be more complex due to the hierarchical structure of the sample. These complexities should be taken into account when deciding on the appropriate sampling method for a research study. Another disadvantage of multi-stage sampling is that it is susceptible to various sources of sampling error. These errors include selection bias, non-response bias, and measurement error. Any errors introduced at any stage of sampling process can impact the validity and reliability of the study findings. To minimize these errors and ensure the integrity of the data, researchers must implement rigorous quality control measures. Another drawback of multi-stage sampling is that it may result in a loss of precision compared to single stage sampling methods. This is particularly true when cluster sizes vary widely or when there is high variability within clusters. Sampling clusters instead of individual elements can increase sampling variability and reduce the efficiency of estimation. As a result, confidence intervals may be wider and population estimates may be less precise. Furthermore, multi-stage sampling can also be time consuming and resource intensive. The process involves identifying and selecting clusters at different levels, which requires significant effort and resources. Researchers must allocate sufficient time and manpower to carry out each stage effectively. Moreover, the need to adjust for unequal cluster sizes further adds to the time and resources required. This can pose challenges, particularly when working with limited budget or tight timelines. Another disadvantage of multi stage sampling is cluster effects. So, when conducting surveys or studies, researchers often use this method, that is multi stage sampling. Instead of randomly selecting individuals, they select groups and clusters and then randomly select individuals within these clusters. However, this approach can introduce what is known as cluster effect or intra cluster correlation. Essentially, it means that people within the same cluster are more similar to each other than people in different clusters. These cluster effects can pose challenges when analyzing the data. They can lead to biased estimates of population parameters and inflate the standard errors, making the results less accurate and reliable. To address these issues, special statistical techniques are needed. Two common methods used are cluster robust standard errors and hierarchical modeling. These techniques help account for the clustering and adjust the analysis accordingly, resulting in more accurate and trustworthy study results. Another disadvantage of multi stage sampling is its potential for clusters of different sizes to occur. This means that some clusters may be larger or more diverse than others. The problem with unequal cluster sizes is that it can result in unequal chances of being selected for the sample. This can introduce bias into the sample, favoring larger clusters or certain subgroups within the population. To ensure that the sample is representative, researchers must carefully consider the implications of unequal cluster sizes and make adjustments to their sampling strategies accordingly. By doing so, they can mitigate the potential biases that may arise from this sampling method. Additionally, multi stage sampling may not always be suitable for all research objectives. Depending on the nature of this study, other sampling methods might be more appropriate and effective. For example, if the goal is to obtain a representative sample of the entire population, simple random sampling could be a better choice. It is important for researchers to carefully consider their research goals and select the most suitable sampling method accordingly. So, in conclusion, we can say that multi stage sampling presents researchers with a range of advantages and disadvantages that must be carefully considered. While it can result in clusters of varying sizes and introduce complexity, it also offers the opportunity to efficiently sample large populations and incorporate stratification. By thoroughly assessing the implications of unequal cluster sizes and making necessary adjustments, researchers can minimize any potential bias in their samples. Moreover, by taking into account the added complexity and logistical considerations, researchers can determine whether multi stage sampling is the most suitable method for their particular study. Ultimately, the choice of sampling method should align with the research objectives and the characteristics of the population being studied. This is all. Thank you.